Hello, everybody. Let's solve problem 2.36 now together. This is one of your homework problems in homework set 3. In this problem, you're going to analyze the circuit by looking at series and parallel resistors and simplifying those resistors into a more simplified circuit. Then, at the end, in order to solve the problem, you're going to apply a source transformation. So let's get started. So we're given a circuit that looks like this. It has a lot of resistors. It has one 10 amp source current, and there is a resistor, a 4 ohm resistor that has a voltage Vx across it. The problem says to use resistance reduction and source transformation to find Vx in this circuit. So we're going to do this by first doing the resistance reduction and then doing the source transformation, and then we'll find Vx. So let's get started. First, let's highlight these to see what's in series and parallel. Okay, I've done the highlighting. Now we can see that there's two branches of 16 ohm resistors that are in parallel on each side. We can see the ones on the left because they are both sharing the yellow node on top and the purple on bottom, and on the right, they're sharing the blue on top and the purple on bottom. So we can tell they're both in parallel. Let's quickly look at how to find the equivalent resistance, Req, for this. So the definition says 1 over equivalent resistance is equal to 1 over resistor 1 plus 1 over resistor 2. Following the math through, we get to an expression that for the equivalent resistance when we have two resistors. And if we insert our number as 16, we can find that 8 ohms is the equivalent parallel resistance. So now let's redraw the circuit, simplified. So we have taken the these and we have added them into our new circuit. So now we have an 8 ohm resistor here and over here. All right. Now, now that we have this simplified, let's color code the nodes again. I've done this below. So this is our new circuit, color coding the nodes. These are our new 8 ohm resistors. And now that I've done this, I can see, okay, these ones are in series. So let's make them equivalent to 12 and redraw it so it looks like this. And now you're probably already seeing, okay, these ones, it looks pretty obvious. We might not even need to color code it, but these ones look like they're in parallel, these two 12 ohm resistors. So sure enough, if we do the highlighting, look at the nodes, we can see, yes, they are in parallel, and that's going to be a 6 ohm resistance. So let's redraw this circuit where we take the 6 ohm resistance, put it in here. Okay, so we're starting to get somewhere. We've reduced a lot of these. So remember, we're doing resistance reduction first, and we've done a bunch of this. Now looking at this, okay, let's color code our new equivalent circuit. And we can see that there's this yellow node that's pretty big and the blue node that's pretty big. Now we have two 6 ohm resistors, and they're on either side of that current source. So does it matter? No, it doesn't matter. We can actually redraw them, right? Because they're in parallel. So just visually, in order to see it better, we can move this resistor over to this side. Now it's very obvious that these ones are in parallel. And we can find the parallel resistors just like we did before. And that equivalent resistance is going to be 3 ohms. So simplifying even more, now we've arrived at this case. All right, so at this point, I think we've done all of the resistance reduction that we can, because remember, our long-term goal is to find Vx, and the Vx is up here. So I think we've just about got this done. Let's take a look now, what kind of source transformations we can do. Okay, so these are the source transformation that we know. We can transform back and forth between these current sources and voltage sources if we have the circuit looking like this. So do we have part of our circuit that looks like this or like this? Well, if we look over here, we can see this is a current source and this is a current source. And then we also have this resistor in parallel with the current source, just like this. So we should be able to transform from this side over to this side. Okay, if we do that, right, we can see, yes, let's make this source transformation. But if we make the source transformation, what is the voltage going to be in our new transformed circuit? Well, let's rearrange this equation to solve for Vs. And we can see that Vs is equal to Is times Rs. So let's take a look in our circuit and see that Is is our 10 amp source and Rs is this 3 ohm resistor. So if we solve for that, we can see that our new voltage source, when we do the source transform, the new voltage source is going to be 30 volts. And the resistor, the Rs, which was 3 ohms here, is going to be 3 ohms again. All right, we're almost done. We just want to find this voltage across this 4 ohm resistor. We've done the transform, so now we have a 30 volt source and 3 resistors in series. So we're very close to finding Vx. We can rewrite the circuit like this, and now we just need to figure out how to find Vx. And we can do Vx using a voltage divider, right? So if we use a voltage divider, we can see that the amount of voltage across this one resistor in the series is going to be equal to the voltage across all of the resistors multiplied by the resistance of the across the resistor of interest divided by the total resistance. Doing this, we arrive at the final result, which shows that the voltage Vx is equal to 8 volts. So in this problem, we used resistance reduction first to simplify the circuit as much as possible. Then we applied a source transformation to this so that we could have a voltage source instead of a current source. This made it very easy to use a voltage divider to arrive at the final answer to find the voltage across the 4 ohm resistor. So thank you for following along, and I will see you in the next video.